Hi, everyone. My name is Nadav Samet. I'm a CTO and co-founder of TrueAccord. Before starting TrueAccord, I was at Google. I was a software engineer there working on a few projects like Gmail, Google Apps, Google Flights, Google Hotels, and I was writing a lot of protocol buffers over there. When I left Google to start my own company, one of the things I discovered is that we are on our own. We have a very limited time to get a minimum product to market, and we want to leverage as many tools that we can find that we're comfortable and we already know. And protocol buffers was one of them for me. We started with Python, and protocol buffers have an official support for Python by Google. And as we moved to Scala, we shifted to the Java implementation that Google provides for protocol buffers. And the cool thing about it is that the Java and the Python wire format, all the wire formats for the protocol buffers, there's a standard, they're all the same. So the Scala server and the Python server could just talk on day one. So I'm here today to talk to you about protocol buffers in general, what is ScalaPB, why we wrote it, when you should use protocol buffers and when you should not, give you a little bit of a taste of the API, and then talk about a few specific things that I learned while I was developing it. So, one of my goals here today is that even if you don't end up using protocol buffers or ScalaPB, which I think many of you, by statistics, will not use ScalaPB by the end of this year, you'll still learn something from this talk, some of the things that I hit while I developed it, and some things I learned about functional programming in Scala that would just be useful for you as you go along. So let's get started. By the way, before we start, is there anybody here that works right now for Google? Great, so I can tell you everything I want. So basically, there are two types of jobs at Google for software engineers. There are people who take protocol buffers from one format and write it to a protocol buffer in a different format. And there are people who manage the people who write protocol buffers in one format and write in another format. So I hope your jobs are more interesting. But basically, a lot of times, this is like a kind of truth, right? In a lot of corporate jobs, you find yourself working with data formats and moving data from one data set, from one source to transform it a little bit, report it, or write it to another place. So let's find a way to make it nice and pleasant to do. So protocol buffers, let's start with the definition, and we'll go with an example in a bit. So protocol buffers is a language to describe data structures. On top of the language, there's an implementation that defines the encoding. How do I take those data structures and serialize them as bytes? Or how do I take the bytes back and get the original data structures? And protocol buffers come with a compiler that generates access class for Java, C++, Python, Go, Ruby, JavaScript, other languages. And with ScalaPB, it gets Scala support. So this is the example. This is what a protocol buffer looks like. I hope this is large enough. This is an example of a person object, and it has three fields. The first two are of type string, the first name and the last name, and then there's an age field at the bottom. And every field comes with a tag number at the right side. It's 1, 2, and 3. And when the message gets serialized on the wire, it says key number 1, that's the value. Key number 2, the other value, the last name. Key number 3, there's the integer that represents the age of that person. And everything in this specific message is optional. So the parsers, they expect that some data will be missing. So you write this file, then you write, this is the protocol buffer compiler, it's called Proto-C. And you give it the protocol buffer and you tell it, create a Java class, create Java source code out of it. And then you get a giant file. And basically, you have an accessor for this protocol buffer in Java. We call Java from Scala in this code sample. So everything in the Java implementation is immutable, and you have builders to create those immutable objects. So you have a person, you call new builder, you set the first name, the last name, the age, you build, and then you can say, give me a byte array. And to get it serialized, we convert it to vector, because Scala is a nice way to print vectors. If it was Java, it would just be like the memory location. So this will be the byte representation. This is a vector of bytes. And you can do it exactly the opposite of that. If you start from an array of bytes, you can do parse from and get the original protocol buffer back. And protocol buffers in the Java implementation come with a nice toString method that would give you a nice, it's very nice for debugging when you're able to print the messages. So another feature of protocol buffers is that you can nest nest messages inside one another. This is very useful to get, to build more complex data structures. So here we have an address of a person, which is just a street and a city. We have a bank account, which is a routing number and account number. And then we add to this person at the bottom the address as an optional field and a repeated bank account list. So this would be a collection of bank accounts that this person has.
Quick question.
Yeah.
Why is there routing number? Why is everything optional? Because bank account without one of these numbers makes no sense.
Right. So we leave it. So the idea here is that there might be some evolution happening to your protocol buffer over time, and maybe you'll decide that you want to represent it in a different way. We don't want the parser to crash. We want the application to take the data and figure out whether it should continue with that optional thing or not. So we'll touch evolution I think, in a bit. You shouldn't use protocol buffers all the time, but these are some good reasons to, to kind of figure out when you should use them. So, and why not JSON, which is a great format and very readable and very common. So you get an efficient binary format. So when we serialize protocol buffer messages, we don't have to repeat the keys. They are just numbers, so it's shorter way to represent them. And the numbers themselves are in a binary format. It's a very, very efficient. You get classes to access the data. So you have this person object, which you can access the fields of it programmatically rather than you having a dictionary of strings of some sort. But the bigger benefits are actually what's coming next. So let's say you want to set up two servers and you want them to communicate in a binary and type-safe way. You can use protocol buffers. One of them can serialize the messages, the other one can parse them, and you set up type-safe way to have the process interact. And the nice thing about it is that as your protocol messages evolve, if you use optional fields, you can have two servers that compiled against different versions of the protocol buffer running at the same time, and without having the programs crash, which is something we're going to touch. Another beautiful thing that you get from these protocol buffer files is that you have a schema that you can share in your company between teams, and you can tell them this is the data structure we have. When you get a person object, this is the fields it has, these are the types. You can add comments between the lines and say, this is what this thing means to me. You can use it as a persistent storage format. You put a protocol buffer in a file. You can read it later on. It's exactly like communication, but more long term. So as the data, there's more likelihood that the data will evolve by the time you read it. And this is, I think, something that a lot of people don't mention when they talk about protocol buffers, is why they're so great for evolving schemas. And this is a little bit a story about us. When we started this company, we had no idea where we were going. We knew that we were going to do about account recovery, and we'll have an account object and a person object, but we didn't know about the relationship. So as we started, the account object was the central thing. And we thought that every account is a person. But as we grew, we started to see that we actually have multiple, we have persons with multiple accounts, and we had to change our data model a little bit. So here's an example of what you can do, right? So you have a person. This is the before we started evolving it. And then this is what it can be after, as you grow. So you decide that you hate first name and last name, so you go with given name and surname. And then you don't like the age field because it's a bad idea to store ages. You want to store a year, so because time goes by and the age changes. And you do something like that. And what happens is that if you serialize a message with a parser that's written in this format, that one can read it. So it will access, because it has the same one is the same tag, this one would, when it tries to access the first name, it will get the given name that was set in that message. So you can rename fields at any time. You can drop field because it was assumed that this is optional here. And you can just add things, and this will ignore them if you try to read them. So let's talk about things you can do. It's add optional fields, remove optional fields, rename fields. You can convert between compatible types. So if you have an int32, you can set it to int64. And if you have a parser that expects int32 and you code it int64, you might get your data truncated, but that's it. I mean, if it's not a concern, then you can always do it. You can even make it a Boolean and get just a 0 or 1. You convert optional fields to repeated. So if something is optional, you make it a vector. It can be a vector of 0 or 1 when you parse that message. You can also get the other way around. If you said something is repeated and you want to downgrade to an optional, you'll get the last thing if it's not empty. Sometimes we figure out, like, we have a payment plan and we want to add a method of payment to a payment plan. Then we figure out actually we want to have more than one. So it's very easy to just say, oh, this field is not an optional, it's actually repeated. But there are things you cannot do. You can't change a field type in an incompatible way. So you can't change an integer to a string, it will just mess up the format. You cannot remove a required field. So a required field is something I didn't show, but basically if you said that the field is required, when you try to parse it, if it's not there, the parser will crash. It will just throw an exception. And you cannot add a required field because maybe somewhere in production, there's going to be something that still makes the old types of messages. Now your new parser expects the required messages, and it will crash. So in general, the conclusion that many people came to is just don't use required fields. If you care about the existence of a field, just check in your application level. Don't rely on the protocol buffer implementation to do it for you. And the required fields are going away anyway. So in Portal 3, they're just not going to be supported. So I want to show a little bit of what a Java protobuf looks like, and this would give us kind of a feeling why we want to do it in Scala. So you start with a builder, and you set the first name and last name, and then you get the address builder, because I want to set the address of that person. And I call set street and set city and build, and I expect to get a person, right? No. What happens is that I have an address builder here, and when I call .build, it builds the address of that person. So the indentation that I put here doesn't help. It's not Python, right? So what I get is I get a compilation error, and it says you have an address because you built an address. You call build on an address builder. You wanted to get a person. So the right way to do it is this. You basically set a person builder. You have to put the builder aside. Then you get an address builder. You populate it. Then you call builder on the other one. And you can just say it adds like intermediate variables. It's not as nice as it could be. And another thing that bothered us about protocol buffers in Java when you do Scala is that Java, back at the time, didn't have support for optional fields. So the protocol buffer implementation in Java says it has what it said, the getters, setters, and hazers. So an hazard is a method that tells you, is that field is actually set in the protocol buffer? So we had a lot of code that looks like this. If it's actually reversed. If it has it, then it's some of that bank account, but if it doesn't have it, you have none. The logic here is flipped, and this is actually one of the reasons we changed it. It's very easy to flip booleans and get the reverse logic. So now that we know what protocol buffers are, let's talk a little bit about ScalaPB and how it fixes some of the problems we saw and create a nice API for accessing protocol buffers in Scala. So ScalaPB is a plugin for Proto-C that generates case classes from your protocol buffer definitions. And it solves the nested fields the update of nested fields with the technique called lenses that we talk about. It adds converters to and from Java. So if you're already stuck with the Java protocol buffers and you want to switch to Scala, it's going to be very easy to live with two of them. You can just compile both of them into your projects, and ScalaPB will create converters to and from those classes, so you can just gradually pull more stuff to the Scala implementation. And it's written as a Proto-C plugin, which is an interesting property of the system. I let Proto-C parse the protocol files. I didn't write a parser for the Proto language. So the Proto-C does all the parsing, and the ScalaPB takes the tree structure and creates the case classes. So this makes it much, much easier for the implementation to support more features of protocol buffer as the language evolves. And this is why we can ship Proto 3 very quickly, probably next week. So this is what it looks like. This is the message person that we had before. And this is the case class you get from it. So everything that was optional here becomes an option there with a default of none. And you get a 2-byte array method. And at the companion object, you can parse an array of byte and get the person back. This is essentially it. So when you start to build those objects, this would be the default way to generate the case classes. So you have the person, you have to assign things. What you don't assign gets the default, the none. And here's how I build the address, right? I have the address, and I have a sum address. And this is better than the builders, but there are a lot of sums. It's a little bit dirty. Another issue that you have with case classes in general when you work with immutable data is that nested updates are really hard. And for example, if I want to change the street of that person, I need to make a copy of it, and I need to get the address, and I want to, it's an optional, so I need to get, and I copy the address itself just to change the street. And this is solved by using lenses. You basically get this syntax, which is much, much shorter. It just looks like an update with an assignment. So I'll talk about like how this is done. Yes?
How do you cover the 22 fields limitation in 210? Case class has 22 field limitation.
You're right. So yeah, in 210, it's bounded to 22. There are ways.
So you actually you don't generate.
So it generates and it doesn't compile. Yeah. There are ways around it. I never had we never had to face it with the system, but there are ways to get some. I mean, there are libraries that you can use that would make it compile. I've just never touched it, but this is a solvable. It's a technicality. It's solvable. So let's talk about nested updates. And this is the classic example of how the problem that lenses solve. So let's say you have this structure. You have a case class of A that contains a B. The B contains a C. The C contains a D. And the D finally contains an integer E. And this is how you initialize it. And this is nice so far. But how do you now change this A, this E that's deep inside the structure to 17? This is how you do it, right, with immutable updates. You have to copy A, to copy B inside it, to copy C inside it, and then finally change D to have 17 inside it. With mutable updates, this is just it, right? So nobody would think that this is better than this, right? At the same time, like, what can we do to get something as close as possible to this? So lenses is the solution to it. And I'm going to give like a quick introduction to it without scary words, without category theory, without all the things. Try to make it something we can all grasp at 7 p.m. So we have lens. And a lens is a getter and a setter for a field inside a container. So if I have a container, some person, and I want to get the address out of that person, I'll have a get method that will get the person and give back the address. The setter will take the address and the person and will return a new person with the updated address. And to make things nice to write, we just have an alias : equals is just set. This is the assignment. So this is a concrete implementation of a lens that accesses the address of a person. It's a little bit truncated because I increased the font at the last minute, but bear with me. We have a get that just takes a person and gives back the address. We have a set that takes an address and a person and copies. You get a copy of that person with a different address, with the one that was shipped through that parameter. That's a lens. So this is how we'd use it, right? You have a person address lens, and you want to set a new address. This is how you call it. It's just applying this function. And because we have the : equals shortcut, we can just write this instead. This is exactly the same thing. Now, the beauty of it is that lens, as mathematical structures, they compose. You can just compose them with one another. So if you have a lens that can change the address inside the person, and you have another lens that can change the street inside an address, you can combine them, you can compose them, and you get a person street lens. So you can get and set the street directly from a person. This is just function composition, no magic. And this would allow you to do to update the street directly through a person with skipping the address part. So you have a person street lens, and you just assign a new street to the person, and you get the updated person. So ScalaPB would just generate those lenses for all the fields, for all the objects, with enough implicits and magic and smoke. You can get, I'm not sure what was the difference between those two lines. So this you can get something that you can access the field in a nicer name, not with the big companion object.
Is there anything special for you on Townsend Street?
That's the address of the old office.
Oh.
So actually, this is a backward compatibility.
A few of my startups were on Townsend.
Yeah.
It's a good street.
Yes. So with enough implicits and traits, we get access to this syntax. which I find really, really nice. You get a person, and you can start from an empty one because everything is optional. So this is initializing the person case class with nothing. And now you start updating it by just sending those, just calling those setters, and it's written in a way that it will update this object. It's like a fold left. They're just running these functions one after another. So the order of those things matter. And you can just access and assign something for the first name. If you have the last name as an option in your system and you just want to assign it if you have it, you can use an optional last name. You can set this thing directly, like a nested field directly. This is what we're trying to actually solve, skip the builders stage. So this is letting you go directly to a nested field at any depth level and assign a value to it. You can do mutations. So a lot of times you want to take something, just change it in some way, call a function on it. So modify is taking the value of this and assigning it again. So it's taking a value from a string to itself. If you have repeated fields, you can just combine, and you have a sequence of accounts, you can just append to your list. And this is how we can do, like, a lot of time when you have account numbers, you want to mask them. So this is how you do it over here without copies and without going into the nested things that we saw earlier. So you get a very concise syntax for mutating nested structure. And this has been, when we moved to this, we delete hundreds of lines of code that was just like build and get builder and all that stuff. So I want to talk a little bit about testing as well, which I also learned a lot of things while I was testing this library. So think about, one of the scary things for somebody who writes a library like this is to open source it, and then people send you hate mail because their data is lost. So I wanted to avoid that part of my life and ship it version 1 with a lot of testing. So think about the testing plan for this. You have 15 primitive types. You have enums. You have repeated, required, and optional fields. Packed repeated fields, which is a way to put the a repeated field of primitive types in a more compact format. Nested messages, you can have default values for fields. You can import other protocol files from different, like if you have a lot of protocol files, you can import them. There's something called one-offs, which is like a C union type. There are maps that was introduced in Proto 3. And you need to be able in Proto 3 to import Proto 2 files. So you have two versions of the language that can import each other. And you need to make sure that your code tests all of these scenarios because things happen when you just combine those features. They can interact. So there's a cool tool called ScalaCheck that if you haven't tried it ever, then you should. Basically, what it does, it can generate random data for you. And you set rules or checks that would pass only if certain condition hold. So for me, the conditions were, do we get the same behavior from Java and Scala? So I wrote some code, which turned out to be very complicated, to generate random protocol buffers. It's complicated not because it's complicated to generate random data formats, but because there are a lot of rules of how you compose it. So I want messages to refer maybe to themselves, but you can't do forward references. So you have to keep a list of what you already defined, and you can't call things from the future. Certain names are just, you cannot use them. Turns out that the Java compiler crashes when you use certain names. What I mean is it generates invalid code when you use certain names. So this is basically a large tree of files and with a lot of imports, and it creates basically a very complicated test case. Then what we do is to generate random data to fill this protocol buffer in, and get it serialized by Java, get it serialized by Scala. How we get it the same thing. This was the testing strategy. By running it on Proto 3, I was able to find bugs in Google's implementation of Proto 3. I reported on GitHub. They'll probably take care of it sometime soon. But it was basically about a case where you have a map, and the value type was exactly the same type that contains that entire map. You get a null pointer exception. So this is a very, very powerful way when you have something with a lot of options, with a lot of complexity, to just generate a lot of test cases for it and just make sure that you're covering everything that's possible. This is what I had. Are there any questions? Yeah.
Could you elaborate on the use cases for this more details?
Sure. So let's say that you have two teams in your company, and you want to set up some client-server relationship with one another. And you want to agree on what you're sending. So coming up with a structure, with a document that says, I'm going to send you messages, and these are the fields that they're going to have. This is what they mean. And every way for them to read it and access it all the time is something that proved for our company very, very valuable, because it serves just as a documentation of the data structures. So it's very good for internal communication between teams in a company. I wouldn't necessarily use it for, if I did a public API, I'd probably use JSON or something more, that people can easily, already familiar and can easily access. For me, it's more like a tool for persisting data or for cross-process, cross-platform communication.
And since probably the application is monolithic, then it probably doesn't make sense to use them, right?
Even if the application monolithic, there might be good use case. For example, if you persist and you want to store the data, and you want to enforce the type safety of the data when you do that, it might make sense. Yes?
You try to evaluate the difference between Alvro, Drift, and Protobuf. Why did you choose them?
So all of them are very good tools, and they are comparable. Some of them have features that the other one doesn't have. I chose protocol buffers because I was very familiar with it with years of using it at Google. So I just wanted to look for something that would be make me productive on day one. What was important to me, and also all these tools have, is cross-language support. Part of our company, the data scientists, use Python, and we wanted to use something that would work with that have bindings to as many languages as possible, so we are not get locked into anything. But all these tools are valid, and everything that I told you today applies to them as well. So all the reasons to use them and not to use them apply to them. They're just alternatives. Yes?
Very random question. So we have, as I think most people have used protobufs for a long, long time, gotten the classical tons of required fields here and there. And you mentioned they're going away in 3. Do you have any idea how painful that transition is? Or?
So the good news is that they're going away in Proto 3, but Proto 2 is going to stay for a really long time. And there wouldn't be a strong incentive to transition. Just like if you write a new Proto file, write it in Proto 3. There's no incentive or big win to move to convert your entire system to Proto 3. How difficult the transition is going to be? It's a good question. So I think when you compile it for the first time, some things will not compile. If you use Java or Scala, right, the compiler will tell you, actually only if you use Scala, because in Java the distinction is not as, you have the hazards that if you don't call them, the compiler will not be able to tell you. But in Scala, we will basically move from option of string to a string. So things will just not compile if you change from a required to option. The compiler will save you, which is part of the reason why we all use Scala, right? The compiler saves us whenever we get in trouble, or before we get in trouble. Yes?
So does the protobuf format have a version number, like somewhere when the first couple of bytes that tells you it's version 2 versus version 3?
No, it doesn't have that. Yeah.
So what's the difference then between version 2 and version 3? How is a protobuf interpreted the difference?
The wire format is very compatible. So what they did in Proto 3 is that they added new features to the language. For example, maps, and there's any type. So if you start to use a map in Proto 3, at Proto 2, it will be a list of messages that each one of them is a key value pair. So Proto 2 parsers will be just able to read it exactly in the same way.
So the difference is in the interpretation, not the word.
Right.
And related question, do you see people over time putting version numbers in their messages?
There's something called self-describing messages, which actually contain the actual definition of the message in the message itself. So a parser could just take it. I have no experience with that, but it's useful for some people.
Like containing entire definition or like version number?
The entire descriptor.
You can do it in Alvro, just include the schema ID. So you
have
need the schema register to actually have access to that.
Yes.
have no experience with proto buffer, but I imagine that the usual use case is, as you said, internal, right? We have one team that already has a system that's everything in Java. And then there's a new team that their expertise is in Scala. And now they want to communicate. Can you use proto? So the Java group already has the data classes. Can you use protobuf to generate from the existing Java classes and compile the protobuf classes so then you can generate the Scala ones? Or would you start with protobuf and generate both?
So there are existing, to repeat the question, there are existing Java classes, and you want to add protocol buffers into the mix, and you want to make sure that, so you'll probably need to write some custom layer that would convert between the old plain Java classes to the protocol buffers, to the case classes, or to the Java protocol buffers. Depends which one you use. Sometimes what we find is that you get those automated classes from the protocol buffer compiler, but you want at some point in your application to move to your objects. You don't, these objects are very shallow. Sometimes you want to add some nice methods on them. With Scala, it's really nice because you can add like implicit conversion to them and just throw more methods if you need. But a lot of time what happens is that you take those case classes that you get from ScalaPB or the class you get from the Java compiler and just write your own business logic with a different set of classes and you just have converters between the two.
So my understanding is that you come up with a protobuf definitions, data definitions, and that can generate classes in many languages, right?
Right.
So now you can have multi-language system talk to each other. But the normal use case is that somebody already has a system and has the Java implementations, and then there is Scala implementations missing from another system.
Yeah.
So you can go from protobuf to a language. You can go from a language to protobuf.
No, that's not something that comes with a library.
Because then that would need rewriting in both systems, right? You have to write the definitions in protobuf and then replace in both systems the corresponding classes.
Yeah. If you have heavy investment in existing case classes, there are probably other tools that you can generate some serialization. The issue with those tools is that they probably expect some version of it on the other language, and then you have less choices about the languages that you can have on the other side. Right. Yes?
So as you mentioned, the fact that everything's optional makes all the fields options, right? And that can go in the way a lot when you're making when you're writing the application code. Is there like a way to make fields required and like avoid this option craft?
Yeah. So what happens is that I didn't show it, but if you know that your field is there, you can call. You have the message, and instead of calling .person, which give you an option person, you can call getPerson, and get the default object if it doesn't exist, so an empty object or the actual object, if it's there. So this is better than person.get, which would throw an exception if the option is none. So this already exists. So you don't have to go. You can go through these options very easily.
But all the field definitions will always be options, right?
Yeah.
And there is no way to, let's say, enforce final types, and then maybe have runtime exceptions.
So Proto 3 is for you. So in Proto 3, they threw all the required fields, and there's no meaning of an optional field because so all the fields are optional. So what they did is got rid of the notion of whether the field is set or not. So there's no way to check if a field is set or not in Java or in the wire format. So if it's not there, it's assumed to have the default value. So basically, you get a 0 for all the integers and empty strings for all the strings. And then if you use Proto 3, you'll see much less options. The only time you see things wrapped in options is for nested messages.
Okay.
Any more questions? Yes.
So one difference with Ever we noticed is, so Ever has separate schemas. And so from what I understand, if you want to support different versions of protocol buffers, you have to have the compiled versions of all of these versions compiled on a class path, right?
Mm-hmm.
So in reality, right? Let's say you evolve your schema. What happens? Do you actually? So if you call it, my browser, right? If you call it something, right, and you have to rename it. How do you like the different versions? So how do you access multiple versions of the same? So of let's say account, right? You have an account and you add some fields to it. and you need to access all the new, right? So you have the original product defined with a name, and then you compile and generated some Java classes. So they have a name account in them. Now you compile it again and have a different thing of account. So how you manage the existence of two different classes?
Yeah. So when you change something in a protocol buffer definition, you always have to assume there might be still pieces, some servers in production that speak the old format. So you have to be defensive of that in your application logic. You say, what happens if I don't have this field? Should I bubble up something for the next list, or should I get my either should return something on the left side, or should I, for the exception, it depends how you do your logic. But it's basically something that protocol buffers say we don't have an opinion on. It's up to the application to guard itself from different versions. So it will not crash. It will give you nones in the optional fields. But you have to write code and say, oh, it's not there. It must be an old thing. Go to that code path.
Right, but what I mean is the closing name. So you basically, you always have the new version only compiled in your application, right? You don't have all the new compiled together because they have the same name, right? So you keep the name of the class, right? And so sort of like you create optional fields in such an order, so you assume it will fully subsume the previous thing, right? But you don't have two classes compiled into the same one.
Yeah, this is not something that's currently possible, I think, with the current implementation in Java or Scala. You can't have the two versions simultaneously on the same JVM.
That's right. So I was just thinking, let's say you want to actually know, so you can go and rename the old thing, and suddenly compile two classes and do something depending on what you want to do, right? But then you would have to manually basically support multiple.
What I would do in that case is basically copy. So if you have the person version 1, you can just copy that thing and call create a copy of that file with a different package name or rename the actual message names.
Yep.
And because you just use the same tag numbers, the same numbers on every field, it will just be able to read them. So basically a protocol buffer message is just a key value store from the tag numbers to the values. So as long as you have things that are compatible, it will just read it.
Right. But you will have to manually manage package namespaces to avoid collisions if you want to do that. So my understanding, I don't know if you guys have similar experience. Like I understand that Ever allows you by detaching the schema. Ever gives you more manageability for this, right? Like you will not have to manually manage language artifact, but you will have a separate schema you can manage. That's kind of what we figured out at home. Others, not just the same difference.
Yes.
So again, on use cases, you mentioned that you started using protocol buffers as soon as you started your own company, right? So you probably didn't have teams and all that and different applications. So can you elaborate on what was your use case and why did you decide to use protocol?
Yes. So when we started, and we have one of my co-founders here, he has exactly the same name as me. This is a very interesting coincidence. He's also called Nadav Samet. So we go internally by senior and junior. So we started we wrote the first lines of Python, and we knew very early on that the data is going to evolve. We started with a little bit of MySQL, and we set up the data structure. We said, oh, this is going to be many tables. So for example, a person can have multiple accounts, and you need to set up a many-to-many table. And as we went along, there were so many schema changes that we figured out that we should throw at least some of the fields, although that change rapidly, into protocol buffers. And this was great at capturing the changes in the system because it was so much easier to migrate schemas of protocol buffer than managing schemas of MySQL tables. So we start with a little bit of MySQL with a lot of tables, and then we start to move parts of these tables to protocol buffers, and now everything is very denormalized. Yes, we use some. It's inspired on a friend-feed approach. We basically use MySQL as a key value store for protocol buffers.
Mm-hmm.
Any other questions?
So before we continue for the next talk, I wanted to say that we are hiring. If you want to move protocol buffers from one format to another in a different company, then you're welcome to join. We are using Scala for all our backend stuff, Akka, Play. We are solving a real tough business problem, and if you want to join a stellar team of software engineers here in the Bay Area and in San Francisco, just join us, and I'm sure you won't regret it. We're building something really great.
So not just because applications, but also between versions.
Again?
Like moving protocol buffers.
Between applications, between languages.
Between versions, version 2 and 3.
Also, yeah, I'm not sure we're gonna go on that adventure. Probably the new protocol buffers are gonna be with version 3 because I really like the map use case. But yeah, there's a lot of interesting things that we're working on that would probably be, if anyone here is interested to hear more about it, I'll be hanging out here after the meetup.